just to kind of circle back and talk about the Amazon infrastructure. So we now have the virtual FXT that runs in Amazon, and the beauty of this is the ease of deployment and the ease of tear down, right? It's all software. It's no longer, you're no longer dealing with bare metal. So the way to kind of kick off the creation of a cluster, a virtual FXT cluster in the Amazon cloud is essentially a pretty straightforward process. You tell it which region you want it in, which subnet you want to set this up in. So there's a concept of a virtual private compute instance within Amazon, which is kind of like your networking domain within Amazon, and you can peel off a private network essentially, and then you create subnets within there, and then you can connect that back to your on-prem network via Amazon Direct Connect, or you can have your own private VPN that goes over the internet. You know, there's many different strategies there, but in the end, when you want to instantiate this cluster up in the cloud, you want to make that as simple as possible. So we've kind of attempted to simplify that process to a certain extent where you fill out this template, and then it kicks off this process that takes about 15 minutes, 10, 15 minutes. And then in the end, you have this cluster, this virtual FXT cluster that is configured against an S3 bucket that is automatically created by all this stuff. So it's already ready to be mounted and start writing data to it, for example, right? Now, that's just a kind of a island of storage at that point. It's just an FXT edge filer and the bucket, and they're coupled together, and that's it. But the story obviously is much larger than that, right? You now have to deal with, well, maybe you have data on-prem that you want to be able to have accessing there, or perhaps you want to have the data that you've put in this S3 bucket that was created by this process to be read by your on-prem compute. So I've put together a little kind of video CAN demo that we're going to walk through to show how this works and how it can be done.
Bernie, where's the bucket identified here?
The bucket is not identified. The bucket is created by this. It's an empty bucket.
But you don't have to use that bucket. So for ease of
this is like
this
I
up,
want a cluster up in the cloud so I can start.
Yeah.
You know, whatever my compute process is, it knows where to find the source data and then populates it on my storage and then kicks off this larger thing. So let me just pull up this.
You doing the video?
Yeah.
Okay. You can do it either way.
Ooh, videos.
Now, while that's setting up, I mean, your past slide with hybrid on it didn't look hybrid to me. When I think of something like hybrid, I think of like MPS, where I have a SAN, maybe in an Equinix, and my EC2 has 10 gig access to that. My local servers have 10 gig access to that. I mean, in that case, there should be no reason why you couldn't use your virtual edition in EC2 and your on-prem, hitting same storage, low latency, hitting 10 gig. I mean, what's your direction for real hybrid, not what your slide showed, which is not hybrid?
So in terms of proximity to connections to provide the ubiquitous access?
Yeah.
I mean, you could get that today by putting physical FXTs in a Equinix colo with your applications. I mean, we do that today for customers.
No, but why couldn't you enable it where your EC2 instances could link with your physicals if you still have that same 10 gig low
absolutely.
latency?
I mean, well, we have this concept. You want to talk about the framing? Is that what you're?
No, is he getting it like global? I missed the initial part of it because I had my head down.
Looking at optimizing.
Are you talking about having an EC2-based virtual FXT in the same cluster as a physical one?
No, so the goal is to not join and spread clusters. The end goal and the end vision with what the global file system is going to be is that multiple clusters exist, but they're fully aware of all the topology of all the storage resources that are configured, and then there is a global configuration across all of these clusters. So there would be no need.
Is that really what your customers are
those
asking for, or is that what you're just doing?
Well, customers are asking for, I want to be able to access any file from anywhere, right?
Yeah.
That's what they want.
We get the use case might be, I'm based in Frankfurt, I'm traveling in the United States, I want my home dir.
And I want it fast.
And I want it fast. That's what we get a lot of.
Right. So at that point, it doesn't make sense to take your cluster that's in Frankfurt and stretch it across the Atlantic Ocean over to the East Coast, let's say the US, right? The idea is you have another cluster in the US East Coast that provides the same exact experience as the user was having when he was connected in Frankfurt, for example.
No, but if I'm on EC2 and I have an instance in Oregon, an instance in Virginia, and then my SAN and other stuff in Equinix, all of that's 10 gig linked. Why can't it be one cluster, look like one
What's the advantage of putting it in one cluster that you see?
I mean, it's really what's your advantage when I say, all right, is there going to be a conflict having multiple global namespaces, which is really just multiple namespaces, not really global. So if I want to move something in one, how are you going to move it in the other one, or be aware of the updates of the location change?
Well, and that's what the global file system functionality is for. So today, we can become aware of that, but the administrator has to be cognizant of, I am going to instruct this cluster to perform the movement of the data, and the other clusters to passively watch and be aware and figure out what's going on.
Is a client going to have to be configured? Let's say I do have a VM which can move data centers, on-prem, cloud, hybrid, whatever. Is it going to have to be aware of multiple different cluster locations and cluster IP addresses and switch between them if I want to grab the file from the nearest one?
No, I mean, no.
That's a benefit of a true single IP global namespace for my NAS, is just having one reference point. And it doesn't matter if I'm in Amazon or wherever, I'm going to be hitting that one.
Well, yeah, no, and that makes sense, except for the single IP part, right? You can't have an IP geographically in different places, right? You can only be an IP can only be in one place at one time, but you can have service endpoints, right? So that you can do tie-ins with DNS, for example, that when the guy flies from Frankfurt to the US and goes, / Avere, it looks up on his local thing and gives him the IPs of the local Avere there.
Unless it was something like you did support NFS 4 and, hey, I hit one IP, it tells me the closest neighbor to actually reference, redirect, get the file there, pull it back.
So yeah, so in the end, where you're thinking is a direction that will ultimately get pulled. We don't have it today. But what you're bringing up is a fair point, and we'll get demand for that as people become more mobile with the solution. But what we're coming to market with today is in response to a lot of applications that are mostly local in the sense of running in EC2 with the on-prem, and we're starting there, and it's just gonna, I'm going to be the optimist. It's going to grow like wildfire, and we're going to get demand for those types of applications being brought into the fore.
Saying that, what's your how long will it take before you do Azure or Avere or?
We're in discussions with a large cloud provider today. That's always I can give you a bunch of loaded answers that could be misinterpreted, but we want to move. We want to really succeed wildly with Amazon. We like them as a partner. We love what they do in the cloud space. We know there's others that we also want to get involved with. And ultimately, we could have another entire tech field day on the vision of ubiquitous data brokering across multiple cloud providers on a cost basis, right? There's a large opportunity here. And that whole market's going to shake itself out. There's going to be some winners and losers, and we'll be interested to see who the losers are ultimately in that space. So, but yeah, we would like to have come today with more than one cloud provider. We will quickly bring on another cloud provider as soon as possible. It's not a 12-month effort to do it, I guess is what I'm driving at. It's porting the IP. Okay.
So I just have a kind of a high-level diagram here of kind of what the demo is based on. So essentially, you have an on-prem data center, and you have your Amazon virtual private cloud. They have their own IP addresses that they're responsible for, and you've set up a virtual private networking link between the two to provide the routing for all the traffic that's flowing between you. So this basically becomes an extension of your network at that point in time, and it's isolated from the rest of the world in Amazon, and it is secure and it is safe, and then your only entry and ingress and egress point is really through this VPN link. So with the on-prem data center, you might have your NAS, you might have a Vault TFD in there, and then you might have some object store, but for the purposes of this demo, we have this Avere FXT cluster on-prem, and he has this volume stitched into his namespace that he's exporting as TFD, right? So clients that mount here are going to see TFD, and they're going to read and write data, and that's going to be cached by this system, but ultimately this is the core file that's responsible for that data, right? Now, as you extend your infrastructure into the cloud, right, with this CloudFormation script that I showed that sets up the cluster, that sets up a VFXT with an S3 bucket that's mounted as S3 by default. That's kind of all that you see at that point in time. And what we're going to walk through in this demo is the configuration and the client interactions that take place here so that you can actually see how the data that's stored here actually becomes available up in the cloud for these clients to read and write. So with that said, let me... So, and it's going to be a little interesting to do the pacing. I talked while I recorded this so that it would kind of work out that way. But here we have our on-prem Avere cluster. It's 3 nodes. And now we're going to look at the namespace. So by default, he's got this namespace path TFD that he's exporting, which maps to that NAS core filer that I showed in the diagram, vol TFD. Right? Here I have a Linux client, and he has a mount point to that on-prem Avere. And if he looks at the directory listing of that mount point, he's going to go ahead and see that TFD placeholder right there, which is sits within the root of the global namespace. And then once you actually change into that directory, you're now in the file system of that vol TFD. So as you read and write files, so here I'm touching a file. This file was created by an on-prem client, for example. And really, this is just, it's a very simple test, but it's really illustrating the full solution here. So now at this point, what I can do is I can go back and the diagram, right, this TFD, I want to make this export available here. So what I'm going to go and do is I'm going to walk over to this VFXT cluster, which is also in my browser, and I'm going to add, I'm going to view the S3 mount point, and I'm going to add some data to there. I'm going to say, hey, look, this is a file that was created by the client in the cloud, written to the S3 bucket. So those are like the 2 self-contained cases. And then what we're going to do is we're going to cross the streams and say, all right, my client in EC2, I want him to read and write some files that are located in TFD. And then my client that's located on-prem, I want him to read and write files from this S3 bucket. So we go back. And here we have our TFD cluster, which is the virtual FXT cluster living in Amazon EC2. It's a 3-node cluster. I'm going to go ahead and look at his current namespace configuration. So this is the default config of the system as it's brought up. It automatically has this namespace path to S3. So that can already be your dumping ground and archiving ground for data. So now I'm in that mount point of the VFXT, and I'm going to go ahead and say, okay, this file was created by the VFXT. So at this point, I can now go back and say, well, now that file has been populated there, I want to go back in here and say, how do I teach this Avere cluster to read and to have access to that data, right? So there's an action that takes place, which means you add a core filer, you configure a core filer, and then you add a junction, which is this namespace glue, essentially, and you teach the system to be able to access that data. So here I say I want to create a core filer of type NFS. I give it a name. In this case, I'm going to call it on-prem, I think. Avere on-prem. And then I give it the network name of my cluster that lives on-prem. So I go ahead and I do that, hit next, accept all the defaults, add the filer, and now it's adding this core filer. So essentially it's going to show up on this list. So now I have my S3 type filer, and then I have an NFS core filer. And now I need to tie the exports from that core filer into my namespace. So I go and I say, I want whatever's on that core filer to be visible in the namespace path of TFD. So I'm going to say I want that my Avere on-prem, and the export that he has TFD I want to make visible to this via, oops. So there's a leading slash there that I got to remove.
It was late.
It was late. I have to redo it here. But essentially, so what this does now, looking at that other diagram, is teaches this cluster, say, okay, I got this core filer on-prem, and I want to make that data accessible to me, to my clients in EC2 that are mounting my virtual FXT. So that is the path back to the on-prem filer. So here I add this junction, and then I'm going to go back to my client, and I'm going to perform a directory listing. I'm now going to see, instead of just S3 being there, I'm going to see TFD in there as well. And then I can change directories into TFD, perform a list of that directory, and see the file that was written there by the client that mounted my on-prem of your edge filer. And then I'm going to update that file. I'm going to add some text to it, and then I'm going to go back to my on-prem client, and I'm going to read through my on-prem VFXT to go ahead and read that data back, and then add some data to it, and rinse, wash, and repeat. So here, we're now on our EC2 client that's mounting the virtual FXT in Amazon. I am going to change my directory to TFD, and now this is the file that was created from on-prem. It was just a 0-byte file because all I did was touch it. But now I'm going to go ahead and add some data to it. And the idea here is this is the action of EC2 clients acting on data that lives on-prem and adding, creating new data or adding or updating that data. And we want that to percolate all the way back to on-prem so that your users and your applications that are running on-prem have access to that data. So I've added this little line there that says this data was populated by my EC2 client. And now what I'm going to do here is go back to this Linux client, look at that TFD mount point, and I should see this file that was just updated by my client in the cloud. So here, oh, there's my file.
Why can't they both just access the same bucket?
Why can't they both just access the same bucket?
Yes.
What do you? Oh, you mean both clusters point at the same bucket?
Yes.
That's a part of our global FS implementation. That's
Not supported today.
to be, yeah.
All right.
It's all about, because you want to get that rate contention handled well. That's
Yeah,
main
the
concern.
global FS is key to preventing simultaneous updates to the bucket, right? And we need to arbitrate that access, and that's the global file system that
And you say you don't have that yet?
Not yet.
Okay.
But it will be coming.
It will be coming. Yeah.
So here, the file that was on-prem was updated, and now I have a line of data that was added by the cloud-based client, right? So now the first line, this was added by the on-prem client, and the second line was added from a client in EC2. So then here, I'm just going to create I don't think 20 files or something like that. I'm going to create 20 files through the on-prem client, and then I'm going to go back to my EC2 client that's mounted to my virtual FXT in the cloud, and I'm going to list that directory, and all those files that I've just created are sitting there and ready to be consumed by whatever application that I'm running in EC2. So this is literally the way that we're going to enable our customers to be able to burst into the cloud without actually having to move their physical assets, data assets that live on-prem into the cloud. They don't have to copy anything, they don't have to rsync anything. The edge filer is the one that provides that abstraction layer to go fetch whatever it is that you need. So there I created the files through my local client, and now I jump over to my Amazon client, and I'm going to perform a directory listing. Now the last part is adding access for these clients running on-prem to have access to whatever data was written in the S3 bucket, right? Because that's the reverse direction, right? So let's just say you have a compute process running in EC2 that's just dealing with data inside of the bucket, right? Those two are co-located within Amazon's infrastructure. So that's a very efficient exchange there. So your application is running and maybe archiving a bunch of data into Amazon S3, but now you're like, okay, I need to consume that data on-prem. And the way that you do that is, once again, you add a core filer to your on-prem system that points into the cloud, and then you take that path name of the S3 and you make it visible to your on-prem virtual FXT, and then your clients can now mount that path and list those files that were populated by the, exclusively within the Amazon infrastructure. So here,
Within Amazon, with the S3, since you are doing encryption, what's happening with the keys, and are you going to do any sort of replicated key management between multiple clusters?
So key management, there's a key management protocol out there called KMIP, which is actually designed to handle all of your keys, stashing and rotating, and keeps all your passphrases and all that kind of stuff. So we're working on integration with KMIP so that we can basically offload that work to the KMIP server. But currently the way it works is you create the S3 core filer, we generate an encryption key. You must save that encryption key off and stash it because that's important if you need it in case of recovery. The key itself is encrypted with a passphrase. But then essentially what you do is, if you want to rotate that key, if you want to change your encryption key, there's an API command or a GUI command. You say, I want to rotate this key, and then we change the key, chain it off of the pre-existing key so that we can decrypt all the existing at-rest data in S3. and then you stash that new version of the rotated key, and you keep that, and you can delete the first version that you had because it's already included. It's chained off of the second version that you have. And stash that away, and that's your recovery procedure. In the event that you lose the FXT cluster, you just spin up a new cluster, feed it the key, and you can start reading your data out of S3.
And we'll be delivering the KMIP client support in December, so it's not like a far off
Okay.
thing.
And then, is that spec compatible, or are you looking at SafeNet's implementation of it?
I mean, the idea of KMIP as a standard, I'm sure there are nuances in the implementations of the various KMIP servers, but really what we're going after is our customers that are planning on using this in production. They generally already have or are scoping out their key management, and we're assuring that the standard flavor of implementation that we're doing is at least compatible with that, and then obviously greater compatible with the overall standard.
So is there any limit to number of junctions that you can perform here? Can you have like 15 different clusters with 10 nodes each?
I think the limit's like 50,000
like
junctions.
I'm sorry?
I think the limit's about 50,000 junctions, and we have a limit of 50 core filers per cluster. So each one of those core filers that I added in was one of those slots. You have 50 slots of those, and then basically you have about 1,000, on average, 1,000 junctions per core filer that you can.
So a
create.
junction is essentially a mounted subdirectory within.
It's like, if you want to think about it, it's like a symlink within the global namespace that doesn't look like a symlink. The client mounts the root of our global namespace. They change into a certain directory, and then they get visibility into the file system that was junctioned into that by our global namespace.
With a lot of medical imaging, I've seen that 50,000 would be less than 1 year of images or projects.
But you don't have to create a junction for every single directory, right? So if they have a file system on a NetApp, let's say, right, that has 1,000 directories, and then underneath that has you just create a junction at the top of the root, and now you've just used one junction and you have access to that entire namespace. And then the last part of the demo here was a file that was created by the VFXT is now viewable on my local on-prem client, and that was updated by the EC2 client.
So what happens when they both try to write to the same file at the same time?
Typical NFS semantics, right?
First one in wins?
Well, yeah, I mean, depends on the offsets, right? If they're both writing for the same offset, the last one in wins, right? That's NFS.
Now in this solution, if on-prem, like if the EC2 instances went down, what would happen with the on-prem S3 directory? Would it just not be able to write anything, or is there any sort of fallback? Because hell,
well, you would have to create the core filer on the on-prem system that points directly to the S3 bucket at that point. You'd have to feed it the encryption key that was used. Right?
So there's no chance of like a failover. If I can't
a seamless failover?
If I can't hit this core filer, then failover to the direct bucket itself.
No, it's not automated. No, I mean, it could be programmatically scripted. Like you could have a failure scenario handling.
EC2 never goes down.
Never.
It doesn't. Come on. No, it's up. No. Those are all parts of sort of the whole puzzle that will come together over time.
So the junction's only supported through NFS, or you support SMB as well?
Both.
Yeah, so you can have like a SMB share that points at the root of your V server, for example.
Right.
And the Windows client that mounts that can traverse the junctions as if they look like directories. They just can't like rename them because they're hard coded into our namespace, right? So it's like a read-only port. The top end of the namespace is read-only, basically.
But if they're SMB, then you would get the locking, right?
With SMB, you get locking within the scope of the cluster itself. The global file system, once again, is what ties locking globally across multiple clusters, and that's the end game vision, right?
Are there options on a per core basis where I can say this bucket, I want reduced storage in this S3 availability?
Reduce redundancy, you mean?
Yeah.
We don't recommend that at all. Amazon did not. It's really just for cost savings for throwaway data. I guess if a customer wanted to do it, they could do it, but in reality, it's not a recommended practice.
Yeah.
I mean, you can create a bucket with reduced redundancy, but it's just not a real great. I mean, if it were scratch data, I guess if you lose it, you don't care. You could do that for the reduced cost.
Can you also set your location or availability groups it's in?
For the virtual FXT cluster?
Well, also, that is an option for S3.
Well, S3 is just within a region, right? It spans all availability zones within a region. It has, there are three availability zones in each region, and the S3 is encompassing of all those
Ubiquitously
availability zones.
accessed.
So whichever AZ your compute is running in, let's just say, it has access to the regional S3. And then you can use our flash mirror if you wanted to mirror to a separate region, if you actually felt that that region could completely go away, which...
Don't say it.
In your slide, I see Glacier. Do you plan TV functionality or
So Glacier...
Glacier.
Yeah.
So the story behind Glacier is we were all in, ready to go, cold storage. We're going to have the frozen layer. We'll put a policy server on it so that you can automatically move, data criteria based back to Glacier. And then Amazon did this thing called a massive price drop on S3 and really created a conundrum for us because, every company has finite resources they can aim at feature sets. And the price parity between S3 and Glacier was just not compelling enough
For the active access that you lost.
to really go there. We also, maybe it was a little bit of a gamble, but I mean, since that time, this was in April, May timeframe, and we really have not had a lot of pressure from our prospects and customers about having that support. So will we never do it? I think we will do it at some point in some fashion, have a tier that we'll call, frozen tier.
Does junctioning force a different caching policy for you guys? I mean, if I got
the
multiple
caching
clusters-
policy is defined on the core so when we add a core filer to our config, that core filer has a caching policy that's associated with it. So whenever you junction into a file system that's represented by that core filer, that's the caching policy that's implemented. Now, when you're asking caching policy, do you mean like
how
read
quickly you
versus write?
destage, for instance, if I'm writing from cluster A versus cluster B, they've got to be at the device almost locked, right? I mean,
I'm not sure I follow.
well, if I have two clusters and I'm trying to write to the same file at the same time, for instance, and I'm doing
Is this a real application, or are you just hypothetically speaking?
I'm just trying to understand the integrity issues here, and I'm trying to write to this file.
Yeah.
And one's an S3 or an EC2 version, and one's an on-prem.
Mm-hmm.
And because you're caching, you're destaging this data at some time later,
Yeah.
right?
Yeah.
So how does this data actually get locked at? Now I'm assuming the cluster that actually has direct access to the core filer is the one that's really being controlling here, right?
Well, yeah. I mean, he's the
You got
final
multiple
arbiter.
nodes in that cluster, so some of those nodes could be actively accessing that core, and some may be a pass-through node, stuff like that.
Well, so within the cluster, we have like this cluster data manager that basically manages the consistency for concurrent operations to the same file or the same directory across the cluster.
Yeah.
Right now, when you're talking a separate cluster, that guy is pushing.
Junction into this core filer, right?
It's the opposite. This guy is junctioning in the core filer that is talking directly to the storage, right? And then the client comes in here and writes some stuff, and a client can possibly come in here and write some stuff, and you're asking, when they converge here, who wins, right? So there are policies, you can configure how long this guy's holding onto the data before he pushes it back. You can make it synchronous.
So it's potentially that he's caching at the, I'll call it
At the
the
edge.
Secondary cluster,
At the second edge.
the second edge, and it may not actually get to the primary cluster until later.
Yeah, absolutely. Depends on how you
So you're not
configure it.
changing
But you
the
can
caching
configure it. You can say,
Oh, you
I don't want to
can?
cache it, or I want it to be synchronous, or you can say, no, I want to cache it, right? It all depends on what your application requirements are, what your consistency requirements are, and whether or not your application actually has colliding writes on the same file.
And then the eventual consistency issues with respect to the cloud and stuff like that, you handle that when I'm talking from on-prem to the cloud, junctioned.
Remember,
Something seems very risque about this. Or risky, I think is probably right.
I'm looking at you like.
I'm sorry.
right?
Oh,
so
man.
here, this virtual FXT cluster here, the way this is configured in this diagram, right? He is talking to this bucket. He has this flash cloud connection to this bucket. This virtual FXT here has a junction
To that.
to this guy,
Yeah.
right? So This guy is not
It's
talking
possible
directly to the bucket.
If I'm on premise and I'm writing to this file in S3, for instance,
Right, it has to flow.
caching activity
your
that happens
client.
at the local cluster, and there's a caching activity that happens at the target cluster.
Yeah, but the caching here is largely irrelevant because no one's going to go here and access data directly.
I'm sorry, what did you just say?
I said the
presumption.
caching here
Is
is largely irrelevant because nobody is going to go and fetch data directly from this cluster, from this bucket. The relationship of FXT cluster core filer to bucket is a one-to-one, and then you can expose that to the rest of your edge filers in your environment, but there's still that one-to-one relationship.
Yeah, my challenge is that if for some obscure reason I've got people writing from different clusters to the same file, the caching capabilities of each of those clusters becomes an extremely important aspect of how this is all going to work or not.
If you have an application that's concurrently writing to the same file from different sites, then and you are strictly concerned with consistency, then you put this guy here into a synchronous writing mode, so that any write that he sends, right? But you're losing the caching benefits at that point in time. But that's what you want because you're now saying, I want to run a distributed application geographically dispersed that's going to update the same file at once. There's just no other way around it. You can't beat the latency. You can't do it.
All right, I understand. Thanks.
No problem.
So we're almost out of time.
Yeah, we are. Almost.
As a sidebar note, we also did put some handling in for, you'd mentioned consistency, so Amazon S3 does have regional
Not
consistency.
just Amazon, any of the object storage.
Well, they have different, they have varying models. But Amazon US standard region, for example, has eventual consistency for get after put.
Yeah.
All of the other Amazon regions, so West Coast, Asia Pac, Europe, whatever, have get after put strict consistency. So if you as long as you put it and get your response, you can turn right back around and get it, except for US East. So we had to add some functionality to the product to handle that kind of eventual consistency.
So we smooth it out. We build in a moving window database to help you handle
the versions of the objects that are put.
Okay, so we're almost at the end of our time. Let's just leave it for questions at this point. Any other questions about two writers against the same? No?
Is there a timeline on two clusters against the same bucket?
No, there's not a timeline yet. It's a non-trivial, we don't want to hurry up and put something out to the market, claim victory, and then spend the next 2 years fixing it. We want to be methodical about how we deploy that particular thing. And we're also really assessing the demand for that yet. Like I said, a lot of the initial demand that we're getting are for compute activities in the cloud.
Hey, where did the company name come from?
Italiano, Avere.
Yeah, Ron.
Ron Bianchini, our founder, he's an Italian American, and he wanted to find a way to say, okay, well, we have data that we hold and that we have, and if you translate that into Italian, the verb avere, it means that.
What?
And we just pronounce it in English, avere.
Avere.
Is that right?
Which I'm sure makes him cringe.
It's a nice
What's
name.
the compression algorithm you're using?
LZ4. Plus with an HC option if you want, which is a little more CPU intensive, but.
Question on the local stuff, not the cloud stuff. Are you seeing customers adopting 40 gig Ethernet?
Yeah, not a whole lot. I mean, there are people that ask about it. Can't say anyone's been like, I must have this.
Lots of 10 gig.
Yeah.
Lots of people just from my previous lives waiting for 100 gig price points to come down to 10 gig price points. 40 gig just feels like an interim step with costs. So.
Now, the actual hardware you're using, who are you OEMing it through?
The hardware that we put our physical FXTs, right now we use Supermicro chassis, but just like with the virtual world, I mean, that's a continuous analysis problem. As the business grows and as we go to multiple regions of the world and supply depots become a concern and other things may change. We don't know. We leave that option open so we can come up with the right solution.
This is my other demo that we ran out of time, but.
Oh, we could have rendered movies for you. We had like 5 in our back pocket just in case we didn't have enough slides. But Everything you saw, we were doing, that's real stuff. There's no fluffware. If during lunch you want to see some of this stuff, we can show it to you. It's for real. Don't worry. Or not during lunch. I may have just stepped out of the rules. Excuse me. But if you have any other questions after the fact as well, we have cards and be happy to answer them for you. We appreciate you guys taking the time, and this was really good conversation. Lots of great questions, and hope it was worth your while.